Hey everyone. So sorry again, I'm not with you today, but we are going to continue with notes 7.3. So at this point, you should have already expanded the problems 5 and 6, and you should have verified your answers with my answer key, which is linked into Canvas. So we are going to actually work through the backside. We are going to work through some of these examples with condensing. Now, condensing becomes far more useful than expanding. Condensing will allow us to solve logarithmic equations because by condensing multiple logarithmic expressions or multiple terms of logarithmic expressions, it condenses it down to a single logarithmic expression, which allows us to apply an inverse property to cancel out the logarithmic expression and solve an equation. Don't worry too much about that. We will get there. So while expanding, we worked through asking ourselves, do we have multiplication? If so, yes, expand. Do we have division? If so, yes, expand. Do we have an exponent? If so, yes, expand. We're essentially going to work backwards for condensing. We're going to identify, do we have any coefficients? If so, move them backwards to exponents. Do we have any subtraction? If so, condense it into division. And do we have any addition? If so, condense it into multiplication. We're essentially going to work backwards through these properties. And it's the same for logs of any base and natural logs, as those are logs in base E. We're going to work ourselves backwards. So here we go. I'm going to start with number 7. So first thing I'm going to ask myself is, do I have any coefficients? I do. I have a coefficient of 6. So I'm going to take that coefficient and I'm going to move it backwards to be an exponent. Now that exponent only applies to the base on the log, in the log, that the 6 is a coefficient of. I'm not moving it to the y because the 6 is a coefficient of log base 7 of x, not log base 7 of y. So I'm going to rewrite, and I have a log base 7 of x to the 6th now minus log base 7 of y. Okay. I now see that I have subtraction of 2 logs of the same base, and we know subtraction condenses to a single log in which we are dividing. Now, which order do we divide? The first term in the subtraction becomes the numerator. The second term becomes the denominator. So I know I am done when I am down to one single logarithm. I should only read log or ln once, one log of a base. Now, should I have multiple different bases? Different story. But if my entire problem starts in the same base, I should hopefully be able to condense down to a single log of that base. Okay, so what about number 8? Number 8, I don't see any addition. I don't see any subtraction. I see division, but seeing division, and I'm going to flip backwards to these rules, seeing division means I can expand a subtraction. I don't want to expand. I want to condense. Our rules right now are condensing. Okay, I do have something though. I have a coefficient. Think about what a coefficient of a negative means. A coefficient of a negative really means I have a -1. And coefficients we can condense by pulling that coefficient back to being an exponent. Now be really cautious as you write that exponent of -1. By writing a -1 as an exponent just like that, it almost looks like it only belongs to the numerator. And that's not the case. That exponent of -1 belongs to all of what was following the natural log. It belongs to all of 1/7. So when you are condensing, it may be in your best interest. Anytime you pull back a coefficient to be an exponent, it may be in your best interest to put whatever follows the log in parentheses. Again, I've said this before, parentheses are not going to hurt you. You may get to a point, like had I put them here, that you said, I didn't really need those parentheses. Awesome, didn't hurt you. But not writing them can hurt you. Not writing them can hurt you. So in this case, we can think about what does it mean to have an exponent of -1? Well, I could take that -1 and distribute it to everything in the parentheses. I also could think of it this way. A -1 means flip that fraction over. And if I flip over 1/7, I just have the natural log of 7. Because this is a 1 and not a 2, 3, 4, I don't need to worry about raising that 7 to any power other than 1, and 7 to the first is still 7. Okay, let's see. What other ones should we do? We will do 2 more of these together, and then I'm going to let you try 2 on your own. Okay, we're going to go to 9. First thing I'm going to ask myself is, do I have a coefficient? Now, I don't have a coefficient of log base 3 of c, but I'm going to tell you we do have a coefficient here. We've talked about writing logarithms, expressing them appropriately. This says a log base 3 of a all divided by 2. It doesn't say log base 3 of a over 2. That over 2 is over everything. Division by 2 can be rewritten in terms of its inverse, which is multiplication. Ask yourself, dividing by 2 is the same thing as multiplying by fill in the blank. And if you said dividing by 2 is the same thing as multiplying by a half, you are absolutely correct. So I'm going to re-express this division by 2 as its inverse, multiplying by a half. Now that I've done that, it's more apparent that I indeed have a coefficient that can be pulled back to being an exponent. That division by 2 is the same as having a coefficient of 1/2. So I'm going to pull back that exponent of 1/2, or pull back that coefficient of 1/2 to become an exponent. Now, here's where rules of exponents come into play. We never leave anything with a rational exponent. We have rational or fractional exponents to help us simplify and condense, but in the end, we're going to turn that rational exponent into a root. So it is not technically a rule of condensing, it is just a rule of exponents. We are going to make that the square root of a. Now notice, I'm not taking the square root of the log, I'm only taking the square root of the base a. The base a has the exponent of 1/2. The log doesn't have the exponent of 1/2, just the a. Okay, let's keep going with our condensing. I also see that I have addition of 2 logs in base 3. Addition of 2 logs of the same base condenses to 1 log in that base, 1 log in base 3, and I'm going to multiply my 2 pieces, c times root a. At this point, we're done because we are down to 1 log in base 3 of this product c root a. Parentheses, do we need them? Technically, no. Parentheses we need when we have multiple terms. But remember, terms are separated by plus or minus signs. This is a product. There are no plus or minus signs. So do I need parentheses around c root a? I do not need them. Can I have them? Absolutely yes. If you're questioning it, just go with the yes, put in the parentheses. Okay, I'm going to let you try 10 on your own here in a minute, and I want to walk through number 11. Okay, number 11, coefficients. We're going to look for those coefficients, and we're going to pull those back first. So we have a coefficient of 1/2. That is going to pull back to be an exponent on x. Plus, we have a coefficient of 3, which is going to pull back to be an exponent on the quantity x plus 1. Okay, rational exponents we don't like. So rational exponent, I'm going to go ahead and switch that to a root, specifically a square root of x. My exponent is the integer 3 in my second term, so I don't need to worry about roots for that 3. But now I see I have 2 logs in base 10 in which I'm adding, so that can condense to a single log in base 10. And again, I don't have to write that base 10, but I am going to multiply root x times the quantity x plus 1 cubed. Now, similar to number 9 up above, do I need parentheses? No, because this says root x times this quantity, and that quantity, those 2 terms are already contained in parentheses, but having parentheses, not going to harm you. Now, some of you may be asking, should I go ahead and perform this multiplication? Should I do x plus 1 times x plus 1 times x plus 1 and then distribute in a square root of x? I can, but I don't have to. I have condensed down to a single log. When we add the skill of solving, this will be sufficient. And when we add the skill of solving, we'll determine from there, do I need to expand or not? So just like I'm going to ask you to try number 10, I'm going to ask you to also try number 12 on your own. Be very careful though. I have different bases. That is going to change things just a little bit for you. Okay, condensing. Great skill for solving, and we'll talk about solving on Friday. But let's do some fun, more challenging problems. Normally, if you were here in the classroom, I'd show you a really old math book from my grandpa. And back in those days, there were no calculators that evaluated logs for you. Instead, you would open up your really, really old math book and you would have a table in the back that would approximate the values of different logs of different bases. You would have to use your rules of expanding and condensing in order to evaluate a logarithmic expression. So, what does that look like? I'm actually going to start down here in 15. If that table gave you these two pieces of information, you'd have to find this. The table's not going to tell you a log in base 4 of 49 over 6. It's going to go with integers, log in base 4 of 6, log in base 4 of 7, log in base 4 of 8, and you're going to have to use that information to evaluate the log. Okay, how can we do this? Well, I see log base 4, I see a 6 in the bottom. That's good. I know log base 4 of 6. However, I need that log in base 4 of 6 to not be in a denominator. I can do that by expanding this expression. I see division, so I can expand it to be subtraction of the numerator minus a log in base 4 of the denominator. Okay, well, we already know what this is equal to. We have a value. That's good. I don't have a value for log base 4 of 49, though. I have a value for log base 4 of 7. So how can we turn this 49 into a 7? Well, 49 is 7 squared. And having that exponent of 2, I can use my rules of expanding to make it a coefficient. So I would have 2 times log base 4 of 7, and I'm going to bring down that minus log base 4 of 6. Now I can go ahead and evaluate. Again, pretend you are really old like my grandpa who was born in the early 1900s and didn't have fun calculator. So by the table in the back of the textbook, it would tell us a log base 4 of 7 is 1.4. So I still have this coefficient of 2, but everything I underline in green would be equivalent to 1.4 minus log base 4 of 6, would have to look that up in the table in the back of the textbook. Log base 4 of 6 is approximately 1.3. And then we'd have to go ahead and evaluate. Multiply by 2, 2.8 minus 1.3, and that is approximately 1.5. Now, we'll talk more about how to use the calculator to evaluate, but just to show you that I actually did use my grandpa's old math textbook. Remind me when you're in the classroom and I'll show this to you. But I did use that to pull these values. And I'm going to type in a log in base 4 of 49 divided by 6. Whoops, I'm going to move that to the denominator. Approximately 1.5148. We got approximately 1.5. Aren't you appreciative of these calculators? So this is how math was done years and years and years ago. Now, 2 other problems for you to challenge yourself, and this goes with the manipulating of exponents that we have done as warm-ups here and there throughout a couple different lessons. I'm not going to walk through these 2 with you, but I want you to try them. Can you evaluate these completely? You don't need any information like this. Can you evaluate these completely without the aid of a calculator? The answers are in the answer key for notes 1.3, but please, 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 when I see you on Friday, make sure you ask questions if you have them. So at this point, you should be completing the 2 expanding problems that are left, 10 and 12, and as well as challenging yourselves to evaluate 13 and 14. Good luck.